Welcome back, geometry students, to section 7, parallel lines and proportional parts. Perhaps you're totally understanding these proportions. Notice we are going to make proportions. There is one small occasion in this particular section where we will not make a proportion, but we should probably talk about the other stuff first. So, we're back to parallel lines. We're still here with proportions. So we're kind of mixing and matching a couple chapters, the parallel lines with the transversals, and then chapter 7 with proportions. So notice the first thing, non-parallel transversals. So notice like AC and BD would be non-parallel transversals. They are intersecting those parallel lines. I know they're parallel because of my parallel arrows, right? That's always an important fact. Those non-parallel transversals can be extended to form similar triangles. So instead of just seeing two parallel lines and then two transversals, if I extend this and I extend this, I'm now going back to another section where I have one triangle sitting on top of another one. Notice I've got the large triangle ABE. Oops. ABE. And then I've got the smaller triangle sitting on top of it, CDE. Those are similar triangles. So we're going to use this similar triangle idea, but we might not always have a triangle, or sometimes we do, and we can set things up a little differently. So we are still looking at proportions and setting up ratios. So the first one is the triangle proportionality theorem. You don't have to memorize that, you just need to know how to use it. It says if one line is parallel to one side of a triangle, so BD is parallel to the side AE of that triangle, and it intersects the other two sides, so it intersects side AC and CE, then it divides the sides into segments of proportional lengths. So the sides get divided up. So what I could say is, looking at this side right here, I'm going to set up a ratio with those two pieces. So CB over BA. CB over BA. So this top part over the lower part. And then I'm going to go to the other side and I'm going to do the same thing. I'm going to put the same piece on top. So I'm going to do CD over DE. You just have to be careful. We couldn't put DE on the top here because DE is sort of corresponding or straight across from AB. So we have to make sure we just line that all up. Once we've got ourselves a proportion set up, we are good to go with solving it, right? So setting up's the harder part. So I think I've got a couple examples. Why don't we just do the first one? In triangle RST, RT is parallel to VU. It says it in the directions. It also says it on the diagram with my arrows. SV is equal to 3, already labeled. VR is 8. UT is 12. Find SU. We all know we put an X somewhere when we're looking at that. So what I'm going to do is I'm going to take my two sides and I'm going to make proportional parts. So you go through the parallel lines. So if I did say, let's see if I can throw you off because this seems easy. If I did 8 over 3 for this top line that I highlighted green, what would the bottom line have to be? Would it be X over 12 or 12 over X? Well, the 8 and the 12 are right across from each other, so the 8 and the 12 have to be right across from each other. Take that, cross multiply. So if 8x equals 36, I believe that x is going to have to be, maybe that's a 4.5. So that seems pretty easy, right? There's one type of problem. So we take those two sides of the triangle that both touch the parallel lines and set ourselves up a proportion. The converse of this, converse means we flip it over. So if a line intersects two sides of a triangle and separates them into proportions, then the line is parallel to the third side. So basically, We don't have parallel markers here. That's the question. So here's what sorry about that. Here's what the questions are going to ask, or it's going to say, are the lines parallel? So is NJ parallel to MK? So it's a yes or no question, right? You have to answer it. It's parallel or it's not. But of course, you're going to show me some math to do that. So you're going to set up a proportion. So in this particular case, we would do the same setup. So I would say, is HN over NM equal to, question mark, HJ over JK? If those two come out to be equal when you cross multiply or check, however you're going to check those, then you'd say, yes, the lines are parallel. If you got two different values when you cross multiply, then nope, NJ is not parallel to MK. So it's the same setup, it's just asking the question slightly backwards. So let's talk about a mid-segment, right? We talked about a mid-segment with trapezoids. Mid-segment I also call a median because I think that's really helpful. A mid-segment is a segment with endpoints that are the midpoints of two sides of the triangle. This is why I think it's helpful to call it a median, because we know a median is in the middle. Notice how AB is congruent to BC, CD is congruent to DE. Now this is the one different part of basically this whole chapter. You are typically not going to set up a proportion because you have equal parts. No proportion because we know that AB is congruent to BC, so just set them equal to each other. We also know that CD is congruent to DE. This is the only part of the chapter, pretty much, that we're not going to set ourselves up a proportion so far. So you could see, right, how this might be, I should add this too. B is a midpoint. That's why it's in the middle. That's why those two congruent parts. D is a midpoint. And hopefully you can see a algebra problem taking shape here. Maybe I give you some information and I say something like CD is equal to 5x plus 2. Segment DE is 4x minus 28. Find x. So we know that we would just set those equal to each other. I'll make that a plus 28. Set those equal to each other, we can solve for x. So no proportion because they're equal. You don't need a proportion if they're equal. There's one other thing with mid-segment that we do talk about, and if you're really paying attention, it's the same thing as when we did trapezoids. And you guys were really good at doing this with trapezoids. So let me just explain this and then I'll tell you the similarity. A mid-segment of a triangle is parallel to one side, and its length is equal to 1/2 the length of that side. So I'll say it this way. Mid-segment or median is equal to 1/2 of the parallel side. So if side FG is 32, side JK has to be half of that, right? 16. Or if I said that side JK is 28, we double it to get to FG 56. This is technically the same. Remember doing this for trapezoids, if this is the mid-segment? And we did the mid-segment equals the sum of the two bases divided by 2. Well, on a triangle, this base right here is 0. So we're really doing the same thing. It's a point instead of a segment. So it's the sum of the bases divided by 2, but we only have one base to worry about. If that confused you, ignore the trapezoid part. All right, so they don't put the problem super nice and neat. They do a little bit of weirdness. You know how they like to set things up confusingly. So in the figure, x, y, and xz are mid-segments. So xy is a mid-segment, which means xy has to be parallel to st, right? It also says that xz is a mid-segment, so xz has to be parallel to yt. So I got a lot of stuff going on there so far. Find xz. Well, here's xz. We know it's a mid-segment, and we know that the mid-segment is equal to half of the parallel base. Well, this parallel base is 13, wouldn't you agree? So that means that xz has to be equal to 1/2 of 13, or 6.5. So it's half of its parallel side. So how about st? So st is this guy right here. Its mid-segment is xy. xy is 7. Well, st is not going to be half of 7, right, because it's longer. So st is going to be 2 double, instead of half, the mid-segment. So double the mid-segment to get to the parallel side. So st must be equal to 14. And last but not least, it asks for the measure of angle RYX. RYX. So this angle right here, mark it in a different color, 3 different colors. This angle right here. Well, this one's interesting because we're still going back to our old parallel lines and transversals. If I call these 2 lines parallel, which they're even marked, and if I made this the transversal, I write over everything. It's hard to see it, but if this is my x, this is related to this 124, those guys would be alternate interior angles, right? So what do you know about alternate interior angles? Remember, they're either congruent or supplementary. These guys are congruent. They're both 124. If I asked you for angle XYT, this angle over here, then you would have to do supplementary angles. They're consecutive interiors, or maybe supplementaries, depending on how you're looking at them. All right, so don't forget that old stuff. Alternate interior angles, consecutive interior angles. Hopefully you've used those, recycled them enough that you know what you're doing with those guys. All right, so last but not least, let's set up some problems. So I put this stuff in here, I'm pretty sure, so you didn't have to write it all down. So let's just interpret it. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. Notice this word, proportionally. Super important. Tells you how you're going to set up a problem, right? You're going to set up a proportion. So over here on this diagram to the right, do you see 3 or more parallel lines? I see 3. They happen to be the vertical lines. DA, EB, and FC are all parallel. I know because they've got the parallel symbols, arrows on them. I've got 2 transversals, line AC and line DF are transversals. So what we can do then is we can set up a proportion. This feels a lot to me like what we just did at the beginning. So I can take on this transversal, I can take my parts. So DE over EF. And then I go to my other transversal. And remember, just be careful what order you set those up in. Because DE is on the top, I have to take the same segment, I guess, AB over BC. We don't know if they're congruent because it all depends on what angle they're intersecting those lines, but we do know that they're proportional. So set yourself up a proportion. The next one, though, same diagram, 3 or more parallel lines are cut off. If they cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So I feel like it's really important to notice that it's got the word congruent in there, right? So congruent tells you equal, so no proportion. This is the second time we're going to set this up. So what this is saying is if DE is congruent to EF, so let's say I just give you congruent dashes on those two, then that means that these two guys have to be equal to each other. Not necessarily the same as DE and EF, but AB has to be congruent to BC. So an equation, not a proportion. So watch carefully for that. This one is a proportion. This one is an equation, no ratios. So look at what it's looking for, or what it's telling you. If it has congruent dashes on it, just make yourself an equation. If it doesn't, then set up a proportion. So in the figure, we've got three streets that are parallel, Larch, Maple, and Nuthatch. The figure shows the distances in city blocks that the streets are apart. Find x. Is there anything indicating that anything's equal here? Right? Is 13 equal to 26? It is not. I'm going to take those congruent dashes off. You might see something and be able to common sense your way through this. However, I made you a nice easy example. It won't always be that way. So since it's not, I'm going to take my pieces from one of my diagonals, or one of my transversals. I'm going to do 26 over 13 for this one. When I go to my other transversal, what does that look like then when I set it up? Is it going to be 16 over x or x over 16? It's got to be x over 16, right? Because I used this section of my diagram on the numerator. The 13 and the 16 have to go in the denominator. So cross multiply, that's going to be like 13x equals some large number like 416. According to my mental calculations, when I divide by 13, x should be equal to 32. Double check me and tell me if I'm wrong. So it's 32 city blocks to get from Larch to Maple going on that street instead of the other. Longer, right? It makes sense because it's kind of more crooked angle. Our last example over here, number 5, it says to find x and y. What would you like to find first, the x's or the y's? I'm guessing you're saying x's, right? Here's some x information and here's some x information. Easy peasy. Does everybody see the congruent dashes on them? These two guys are equal, right? No proportion needed, so 2x plus 2 has to be equal to 3x minus 4. So I'm going to do some quick solving here. Subtract 2x and add 4. So it looks to me like I'm going to have 6 equals x. No problem. That was an easy solve. Here's the thing. What am I going to do about the y's? My y information is all down here. So for my y's, because the two top parts were congruent and it was given to me, these two parts have to be congruent, and I can just set myself up another equation. It looks to me like an 8/3 y plus 7 has to be equal to 5y. Now, I'm not sure if you object to fractions, but if you do, here's a nice painless way to get rid of this. I hope you already know this, but your denominator is a 3. There's only 1. So I'm just going to multiply by 3 on both sides of the equation. I have to remember to distribute on the left over here, though. So 8/3 times 3 gives me an 8y plus 21 equals 15y. Easy solve from there. So let's see, I'm just going to go ahead and subtract 8y over here. So if 21 equals 7y, that one I definitely can divide. Y is equal to 3. So 2 problems, one super easy, one a little bit more thinking, but Remember, you can always get rid of the denominator. I wanted to make sure I showed one where we needed a proportion right next to one that we have congruent. The reason we could do that last one with congruent was because these two top pieces were marked congruent on the diagram. Therefore, I know they're equal. Therefore, I know the other two with the y's are equal. And that is it for section 7.4. Thanks for sticking around. I'll see you next time.